Hey, SM2. So this video is for the purpose of the online learning day that is happening on Wednesday. Um, Now, what we were planning on doing for Wednesday, we were supposed to take the Chapter 5 test, so that will be postponed until we are back. And until then, I figured we might review some things that we'll talk about in the next chapter, which is angles and triangles. So for today's online learning day, or for the online learning day that's going to happen on Wednesday, I would recommend one of two things, or both, if you have the time. But one, definitely study up and make sure you are prepared for Chapter 5 test. And if you do feel like you are, great. I'd recommend learning a little bit of what we're going to be talking about here, which is complementary and supplementary angles. So I'm going to go over a couple of these examples and definitions, and if you guys are able to, please find the time to complete this worksheet right here. Again, I would just prioritize the Chapter 5 test, reviewing for that, and there is a review for that. Okay, so for complementary and supplementary angles. Now, a complementary angles means these are two angles that add to be 90 degrees. So, angles that add to 90 degrees. Supplementary are angles that add to 180 degrees. Okay. Now, a 90-degree angle is an angle like what you see in these examples here, and a 90-degree angle is typically denoted by this right here, where you have a pretty much a square right there in between two angles right here. So this is to tell us that this is a 90-degree angle and this is a 90-degree angle, 90-degree angle. A supplementary angle, which are angles that add to be 180. Now, a line like what we see here, if we were to measure an angle from here to here, that would be 180 degrees. So that must mean this angle, and this angle have to be supplementary because they add to be 180 degrees. So we're in the next unit, we're going to be using these definitions of complementary and supplementary angles. And so yeah, make sure you know those definitions here. Now what we're going to be doing here is just solving for missing angles. So here, if we're given these angles right here, it says for number one, find the measure of angle B. So we want to find the measure of this angle right here. Okay, given that this angle right here is 51, and what we know is that the sum of these two angles have to be 90 degrees because they are complementary. And we know that this is a 90-degree angle because of this notation right here, or this marking right here. So 51 plus whatever this angle has to be, whatever angle B is, has to be equal to 90. So if we make an equation of 51 plus B has to be equal to 90, we give ourselves an algebraic equation that we can solve for. So here I can subtract 51 from both sides, and I end up with B equal to 49 degrees. So this angle, which is 49 degrees, which has to be angle B, plus 51 is equal to 90 degrees. Okay. Now here, for example 2, we're given that this angle right here is 90 degrees. Now keep in mind that these two angles also have to be 90 degrees because this is a flat line right here. And if it's split right here, this is 90 degrees, that must mean that this right here has to be 90 degrees in order for them to add to be 180. So with that in mind, I know that 31 plus angle B has to be equal to 90 degrees. So I can subtract 31 from both sides, right there, and I end up with B is equal to 59, I believe. Okay? So I think that's pretty much it when it comes to those right there. Okay, now if you guys could try maybe doing 3 and 4, I'm going to try doing a couple other ones. In these examples here, they're using, we want to find the value of x. Now we're going to be using the same idea. I know that these two angles together have to be 90 degrees. So let me take 56 degrees. So 56 degrees plus whatever angle this is, and the only thing it tells us about this angle is that this angle right here is 3x plus 7. So I'll do plus 3x plus 7 has to be equal to 90 degrees. So now I just have an algebraic equation again. It's a little bit more complex, but really not much. But in any case, how I'm going to go about this one is first to combine any like terms. So 56 and 7, these are like terms that can be combined. So if I add those together, I end up with 63 plus 3x is equal to 90. Well, I'll subtract 63 from both sides, and I get 3x is equal to 27. And then I divide by 3, I get x is equal to 9. Now, let's check our work. So if I plug 9 right here, I should get 3x, or 3 times by 9, so 3 times by 9 plus 7, which is 27 plus 7. So this angle right here has to be 34. Now, to double check, remember that this angle and this angle have to add to be 90. So 56 plus 34 does indeed add to be 90. So x here has to be equal to 9. Okay. So we're just making equations from these given diagrams here. So here I could, I'll try and do 6 in an alternative way. Thing is, I know that this angle right here has to be 90 minus 48. So if I do 90 minus 48, I know that this angle has to be 42. This has to be 42 degrees, but I'm solving for x, right? So this angle and this angle, which are the same, I can write that as an equation. 3x plus 6 has to equal 42 degrees. Okay, this is another way of doing it here. So I can subtract 6 from both sides. Okay, I'll get 3x is equal to 36. Divide by 3. Divide by 3. So x is going to be equal to 12 here. And again, you could always check. So if I plug 12 in there, so 3 times by 12, which is 36, plus 6 is 42, and it ends up checking out. Okay. So again, these shouldn't be too difficult, but go ahead and try doing the rest of these examples here. I'll just include this one page right here. But in any case, I just wanted to introduce this because we'll be using a lot of this examples like these in the next unit. Okay, so hopefully this was informational. Hopefully we can put it to good use in the future, and hope you guys have a good online learning day.